Okay, so this lesson is for Mrs. Cucci's College Now Pre-Calculus class. We left off lesson 3.6, Polynomial and Rational Inequalities. We were on page, I believe 1.10, maybe 1.9 for you. I may have inserted a page. So please find this portion of the document and we can get started. Okay, so some inequalities involve rational expressions and functions. These are called rational inequalities. To solve rational inequalities, we have to make some changes to the method that we used last time. They're not earth-shattering changes. They're just a slight change here and there. Okay, so here's our first problem. We're going to do 3x over x plus 6 is less than 0. Okay, so what we're going to do is we're going to look for all values of x for which the related function is not defined or is 0. We call these critical values. So what we're going to do is we're going to look at the denominator and the numerator kind of separately. Okay, so the first thing we're going to do is we're going to take a peek at that denominator. What value of x is going to make this function undefined? What value of x would make my denominator 0? And we know very quickly that that value is -6. The other piece of this is taking the numerator, and I can rewrite it as an equation if it makes it simpler for us to see. We're going to take that numerator and we are going to take the numerator and set it equal to 0. And very quickly we get x equals 0. So what we've done is we've created some critical values to use. So -6 and 0 are our critical values. So what we're going to do is we're going to take those critical values, and just like before, we're going to take them and we're going to put them on a number line. So here's our -6 and our 0. And we're going to do our test points like we did before. Okay? So, we start our test values. We have a couple of intervals to work with, from -infinity to -6, and then from -6 to 0, and then from 0 to infinity. So we have 3 pieces that we actually need to do. So the first one, we could pick a value that's less than -6, so let's say -7. If we were to plug in a -7, we would get a -21 over -1, which is a positive. Between -6 and 0, let's say we choose a -1. We get 3 times a -1 over -1 plus 6, which gives us a -3 over 5, which is a negative. And then let's say f of 1. 3 times 1 is 3, which is a positive, obviously. And 1 plus 6 is 7, which is also a positive. So there's my positive. Now this wanted where it's less than. So we're looking for where my function, or my inequality, I should say, is negative. And that's only on one interval. And that interval is from -6 to 0. And the reason I'm using the open brackets, because this says less than, it doesn't say less than or equal to. The values of -6 and 0 are going to be my critical values. You're either going to make it undefined or equal to 0. So we don't use those values. Okay? All right, so that's not too bad. It's very similar to what we just did before, except we're dealing with the numerator and the denominator separately, and we're finding what's called critical values. So let's take a peek at the next one. X minus 3 over x plus 4 is greater than or equal to x plus 2 over x plus 5. Okay, so just like with the polynomial inequalities, we do want 0 on one side of the inequality. So we're going to start by subtracting this over. Okay. So again, we're going to look for all values of x for which the function is not defined or is 0. So again, these are called critical values. So the first thing we do is we take a look at the denominators. what values of x would make that function undefined? And we can very quickly say -4 and +5. So then the next thing we need to do is we need to take a look at the numerator. Okay? But before we can do that, we kind of have to get that numerator by itself. And the way we do that is through doing some algebraic manipulation. So if I were to take this and make it an equation, what I would want to do is I would want to clear my denominator. And in order to clear my denominator, what I would do is I'd have to multiply both sides by something. Okay? So to clear it, what I'm going to multiply by is x plus 4x minus 5. Okay? So now when I multiply my first term by this, those x plus 4's cancel. But what happens is now I have x times 3 times x minus 5 minus, and here my x minus 5's cancel, but I still have that x plus 4. Okay. So now what I have to do is I have to FOIL x squared minus 8x plus 15 minus x squared plus 6x plus 8. Distribute x squared minus 8x plus 15 minus x squared minus 6x minus 8. Combine my like terms. -14x plus 7 equals 0. And very quickly we can solve that to be x equals 1/2. So I've got a couple of critical values, right? Critical values. I've got -4, I've got 1/2, and I have 5. Those are my critical values. So we actually have 4 intervals in which we need to deal with. So we set up our number line. We place those on there. And we start testing. So the first one we're going to test is something less than -4. So the quickest one would be, let's say, -5. And again, this is something that I would store into my calculator and pull up a value for, because this is kind of a messy thing, and we don't want to have to do it over and over and over again. You can also graph this function and look at the table. That'd also be another very quick, easy way to find values. And for the sake of time, I'm going to tell you it's 7.7. So we know this value here is positive. Between -4 and 1/2, let's pick -2. And we get a value of -2.5, so that's negative. Between 1/2, oops. Okay, so now we need a value between 1/2 and 5. So 3 is a nice value to use. And that's going to give me 2.5, which is a positive value. And then above 5, we can use 6, which is going to give us -7.7. So there's our negative. So now this wanted where it was greater than or equal to 0, so where it's positive and equal. Okay, so there's where, oops, I'm a little crazy with my pen here. Okay, so where it's equal to 0 was at 1/2. Okay, so we have to include that value. -4 and 5 was where it was undefined, so we don't include those values. This thing is too close to my pen button. Okay, so we're going to have for a solution -infinity to -4 not included, and then 1/2 included to 5 not included. Okay. All right, so to solve rational inequalities, first you find an equivalent inequality with 0 on one side. Then we change the inequality symbol to an equal sign and solve the related equation. Find the values of the variable for which the related rational function is not defined. And then the numbers found in step 2 and 3 are called critical values. We're going to use those critical values to divide the x-axis into intervals, then determine the function's sign in each interval using x values from the interval or the graph of the equation. Select the intervals for which the inequality is satisfied and where the inequality symbol is greater than or equal to or less than equal. Then the solutions to step 2 should be included in the solution set. The x values found in step 3, or where the function is undefined, are never included in the solution set because, again, that's where the function is undefined. It does not exist. Okay, so hopefully you got a pretty good grasp of this, and now this is a shorter lesson, so I made up for some time that I used yesterday. So come prepared with any questions that you have, and again, if you have questions right away and you want to tweet them to me so that you don't forget tomorrow, you can do that. Okay, so feel free to shoot me a tweet with a question. All right, guys, I'll see you tomorrow. Bye.